Alright, we are on lesson 25. Our objective says I will be able to differentiate between relations and functions. Relations and functions using definitions and the vertical line test. So we want to know what the definition for a relation is, what the definition of a function is. So the first thing we need to do is go over some quick definitions. The domain of a set is the set of possible values for the independent variable. So the domain is all of your x values. The range of a set is the set of possible values for the dependent variable. So domain is x, your range values are y. And then a relation is just a set of ordered pairs. A relation is just more than one ordered pair. So a relation might be something like this. -2, 1, and then 2, 3. That's just a set. Oh, let's close that parenthesis. That's just a set of ordered pairs. That would be a relation. So what we've got to do is first give the domain and range of the relation. This is more than one ordered pair, so it is a relation. The domain, we said, is just my x value. So all I'm doing is listing all of the x values, or all of the independent variables. I'm going to underline all of my x values. X values come first in a set of ordered pairs. So the first x value I see is 2. I'm listing them from least least to greatest. Smallest one I see is 2, so let's go 2. I see another 2, but I don't write it again. Just write it once. 2, and then, what is that? 3, 4, 5, and 8. I write them from least to greatest, and I do not repeat them. So 2, 3, 4, 5, and 8. That is my domain. My range. My range is just my y values. Range is just my y values. So my range, the smallest number I see here, put a box around my range. My range is 1. I see 3 6s, but I'm only going to write it once. 1, 6, 9, 10. 1, 6, 9, 10. I go from least to greatest, and I just write them once. That's my domain and my range. Domain is x, range is y. Flip over to the back. A function is a mathematical relationship pairing each domain with exactly one, underline that, exactly one value in the range. So it is a function. A relation is a function when each x value is paired with exactly one y value. So let's check the first one. This 3 is paired with this 3. Alright, we're good. This 10 is paired with this 1. This 0 is paired with this 3. This 8 is paired with this 9. This 4 is paired with this 4. This 10 is paired with this 2. But earlier, 10 was paired with 1. So this is not a function because there is a 10 that is first paired with a 1 and then it's paired with a 2. So no, the 10 is paired with more than 1. The 10 is paired with more than one y value. In order for it to be a function, each x value has to be paired with exactly one y value. If there's a repeating x value, like this 10 here, this 10, it repeats, and it's paired with a different number, so it is not a function. This is not a function. B says to determine whether y equals negative 1/2 x minus 1 represents a function. So I wrote this, I picked some domain values, and now I'm going to figure out, based on these domain values, I just picked these. These are random. -6, 0, 2, 5, 7. I just picked me some random numbers. I included a negative, I included 0, and I included some positives. If I plug these domain values, remember, domain is x. If I plug these domain values in, I would get the following values. This is what would happen. I'm not going to work it out, but if you plugged in all of these values, you would get this. You get -4, -1, 0, 3/2, 5/2. Basically, this is the output you would get for plugging in this. So if I went -6 times 1/2 minus 1, I get -4. -1/2 times 0 minus 1, I get -1. So now I need to figure out whether or not this is a function. I'm determining whether this is a function. Okay? I look to see, do I have any repeating x values? No. Each x value is paired with exactly one y value. This is paired with this. This is paired with this. So yes, this is a function. Each x value is paired with exactly one y value. It is a function if each x value is paired with exactly one y value. Another way you can tell it's a function is if you graph it. If you graph a function, you can do something called the vertical line test. On the vertical line test, if you draw a vertical line, and this, so here's a graph. This straight line is a graph. Okay? If I draw a vertical line, and it intercepts my function in exactly one place, then your relation is a function, because it means there's no repeating x value. If I draw a vertical line, and it intercepts it at exactly one place, then you know that it is a function. So this would be a function. Here, I draw a vertical line, and I notice that this intercepts my function in two places. It intercepts it here and here. If it intercepts your function in more than one place, then it is not a function. So this would be not a function. So this would be a function. This would not be a function. This says to use the table and graph the ordered pairs on a coordinate grid and determine whether the ordered pairs represent a function. So here are the ordered pairs. I already graphed it for you right here. Basically, you might have a problem that looks like this. You would first have to graph these ordered pairs and then tell whether it's a function. Well, let's figure out if it's a function. I can draw a vertical line anywhere on this graph. It's never going to intercept in more than one place. I have no repeating x values, so yes, this is a function because it passes the vertical line test. This is a function because it passes the vertical line test. That is all for lesson 25.